Now we will discuss theorem 2, which is related to the continuity of functions. It is in page 158 in your textbook. So the statement is like this. Suppose you have two functions again, f of x and g of x, and both are real valued functions such that f circle g is defined at x is equal to c. So at the point x is equal to c, you are able to define a composite function which is f circle g. Then if at all you are able to observe that g is a continuous function at the given point c and f is a continuous function at g of c, then f circle g is said to be continuous at the point x is equal to c. So that is the statement here. So let's see how to apply this problem. See, if you look at example 19 given in your textbook, the function given is you need to discuss the continuity of the function f of x is equal to sine of x square in the real numbers. So if you look at the domain of this, the domain is x belongs to R. You can substitute any value, you are going to get a finite output, right? So we need to discuss the continuity of this. For that, if you observe, till now we were concentrating on sine x. Here the function is not sine x, rather it is sine x square, means it is a composite function. Okay, so how did you get the sine x square? If suppose I call this f of x as, so this f of x here, it is a composite function of two other functions. Okay, see, don't get confused. It is not necessary that everything should be measured and everything should be considered only in terms of f and g. You can take other variables also, not an issue. Since here f of x is given as sine of x square, I am trying to write f of x as a composition of two other functions g and h, where I am trying to say g of x is sine x and I am calling h of x as x square. Then what will g circle h of x be? It will be sine of, in the place, so g circle h of x is nothing but g of h of x. This we have learnt in functions. So g of h of x means sine of, in the place of x we need to substitute x square. So this is nothing but f of x, right? Now we need to discuss the continuity of this composite function. So for that, what we are going to do is we will apply this theorem. So instead of having it as f and g, have it as 1 and 2. If the first function is continuous and the second function is also continuous, then you can say that the composition of the function is a continuous function. So here it is a combination, sine of x square is a combination of sine x and x square. So here I am directly writing on point C. The domain is x belongs to R. At x belong, for the value, for any value of x that belongs to R, we know that sine x is a continuous function. Similarly, for any value of x belongs to R, we know that h of x is also, x square is also a continuous function. So since both are simultaneously getting satisfied, we can say sine of x square is also a continuous function. Okay, so as I told you, first and second. So since the first function is continuous, second function is continuous, where in the given domain the combination of these functions, the composition of these two functions will also be continuous, means sine of x square is also a continuous function in the domain x belongs to R. See, not every time they will give you the domain. It is your work to find out the domain and start thinking in that way. Now similarly, f of x is equal to mod of 1 minus x plus mod x. If you observe this, see, f of x is again a composition of two functions. What is it you have? You have an algebraic function that is 1 minus x plus mod x, and that is present within another mod. So similar to the previous problem, I will assign this f of x to two other functions g and h. I will write it as g circle h, where I am writing g of x as 1 minus x plus mod x. Okay, and I will write h of x as mod x. Okay, so when I write it like this, then what can we conclude? Then observe the g of x. This g of x is nothing but 1 minus x plus mod x, right? So what will g circle h of x be? So g circle then I'm sorry, I'll write this as h circle g. H circle g. Then what is h of g of x? So h of g of x is already mod x. So mod of, in the place of x, I need to substitute this 1 minus x plus mod x. Okay, so I'm I'm sorry, I made a mistake. It is not G circle H, it is H circle G. So I'm writing it as H of G of X, 1 minus X plus mod X. Now what is our work? If you need to prove that this whole function is a continuous function, we need to see whether G of X is continuous and H of X is continuous. If both are continuous at the given point, so since the question is for every real number, again the domain is going to be a real number. So here what we will do is, we will observe this. So when you observe this is 1 minus x. 1 minus x is a polynomial function. We know that polynomial functions are continuous. And similarly, mod x. Mod x is also a continuous function in the given domain. Again, when we apply the algebra of functions, in algebra of functions, I told you if f and g are two continuous function, then f plus g will also be continuous. Since 1 minus x is, if I take it as f, so don't get confused with this f, I am just trying to relate it to the theorem. If you are getting confused with it, I will write it as first and second. If the first is continuous and the second is also continuous, then 1 plus 2 will also be continuous. I am taking this thing as first function, this as the second function. Since this is continuous and this is continuous, the sum of these two will also be continuous in the domain x belongs to R. Similarly, h of x is equal to mod x. I already told you mod x is a continuous function in x belongs to R. From this what we can conclude is h circle g, that is h of g of x, is also going to be a continuous function, but h of g of x is nothing but f of x. So it is going to be a continuous function. So in this case what you need to do is you need not take any of the limits. It's a theoretical question. So you are just applying this theorem by writing the theoretical aspects. Similarly, if you observe the problem, the exercise problems which are based on this concept is in page 161, the problems are 31, 32, 33 and 34. These are based on the composition of functions and their continuity. So these are the steps you need to follow.